Good morning, students. Welcome to the virtual classroom. In our last lecture, we have seen some certain numericals based on the equilibrium constant. Today, we will be going through the next topic, and that is related to the factors that are affecting to the equilibrium constant. Factors that affects equilibrium. The factors that affects the equilibrium. Now, which are those factors? The factors are like temperature, pressure, concentration. They affect the equilibrium. At the same time, equilibrium is not affected, but time required to reach equilibrium is reduced by catalyst. Right? So we want to understand what are this, or what is the effect of these factors as an external factors to the equilibrium. These was very first time studied by the scientist named Lecture-7, and that's the reason why the principle was developed for the factors affecting to it were known as according to Lecture-7's principle. So what was that principle? He told it that whenever any external factors that effects are changed, their effects are changed during the reaction, then the reaction will attain the equilibrium in such a way that those change are minimized. Right? What does the principle indicates? Lecture-7 principle indicates that when any external factors are changed, then during the reaction, then the equilibrium gets disturbed, and the new equilibrium is established in such a way that the reaction will establish the new equilibrium, so that whatever the change is done during the reaction, it's been minimized. If you would have increased the temperature, it will proceed in such a way that it will reduce the temperature. If you decrease the temperature, it will increase it. If you try to change the concentration, like if you decrease the concentration, it will increase the concentration of the reaction. Right? At the same time, this will also help me to know it whether the reaction will proceed in the forward direction or in the reverse direction. So to predict it also, this principle is going to be helpful. Now let us see how these factors are going to be affected in each by taking it as an example of the different reactions and try to understand. Or even the question will be asked to you that in the given reaction, if concentration of the component is reduced or concentration is increased or temperature is increased or reduced or pressure, how will you recognize that whether the reaction will proceed in the forward or reverse direction? So for that case, let's take it as the first one. We'll take it as temperature, the effect of temperature. Now, when you are going in for the effect of the temperature, you will have to recognize that whether the given reaction is endothermic or exothermic. The very first thing is the reaction should be known to us whether it's an endothermic or exothermic. Here heat is absorbed. What will get it? Heat is absorbed in an exothermic. That means in the reaction heat is added, that is delta H is positive. The value of the delta H will be positive. For the exothermic, heat is released. That means in the reaction heat is evolved. Delta H will be negative. For such reaction, the delta H will be negative. Now, in that case, for example, CaCO3, when it is heated, it gets converted into CaO plus CO2. That means I can say that this reaction is endothermic. The reaction is endothermic. Now, when the reaction is endothermic, what will happen? Heat is being taken away. Now the question arises, in this reaction, if temperature is increased, now in this reaction I am increasing the temperature. Now what happens? See, already it needs a temperature, and by utilizing the temperature, by utilizing the heat, it is getting converted into CaO and CO2. Right? And if I provide the temperature, what will happen? It will utilize it. It will try to reduce the temperature, so it will proceed in the forward direction. So this shows that it is by increasing the temperature, reaction by doing so, it will proceed in the forward direction. But in place of that, if you say that in place of increase, if we write decrease the temperature, so it already needs the temperature, and still if you take away the temperature from here, from the component, if you take away the temperature, what will happen? Will it get converted into CaO, CO2? No. In the presence of temperature, it is getting converted into CaO and CO2. So in the absence, it is not going to get converted into calcium oxide and carbon dioxide. So what will happen? It will proceed for reverse. So by decreasing the temperature, reverse reaction takes place. Right? So in common for endothermic reaction, for this you can say for endothermic reaction, increase in temperature will go for forward reaction. For decrease in temperature it will take it for reverse reaction. Right? So it depends upon the reaction whether it's an endothermic or exothermic. Right? Now in place of that, let's take it as an exothermic. N2, 3H2, 2NH3 plus heat is evolved. Heat is given out. So what does it show? Energy is released. Already the temperature of this component is going to increase more and more. And in that condition, if I say that by increasing the temperature, what will happen? So if I increase the temperature over here, already the temperature is high, plus again the rise in the temperature, so reaction will try to go for reverse. So for endothermic, increase in temperature. For endothermic, what does it show? Increase in temperature, the reaction will go for reverse reaction. Decrease in temperature will take for forward reaction, and will try to minimize that effect according to the Lecture-7 principle. So for effect of the temperature, you have to be careful whether it's an endothermic or exothermic. If it is an endothermic, increase in temperature will take the reaction for forward direction, and decrease in temperature will take the reaction for reverse direction. Similarly for the exothermic, increase in the temperature will take the reaction for the reverse direction, and decrease in the temperature takes the reaction for forward direction. Right? So that was the effect of temperature. Now let's go in for the next one, effect of concentration. The second term, effect of concentration. Now, in this case, we don't have any partitions. Concentration means we can have it, we don't have it like temperature, endothermic, exothermic, we don't have any two parts for it. It's a one and the same. N2, 3H2, 2NH3. Right? I will write in this reaction, and in that case, here if we say that if concentration of N2 or H2 is increased, then what will happen? If N2 or H2 is increased, then what will happen? The reaction will proceed for forward direction. It will try to reduce the reactant. If you are saying it that if concentration of NH3 is increased, it will go for reverse direction. Right? Though in the case I am putting it as an increase, in both the cases I have put it as an increase. But still one is going for forward, one is going for reverse. So from this, what it can be said, if the concentration of the reactant is increased, reaction will proceed for forward direction. If the concentration of product is increased, reaction will proceed for reverse. So in general, increasing concentration of reactant, reaction will go in forward direction. Right? And increasing concentration of product, reaction will go in reverse direction. So depends upon the effect. Now vice versa for it. If concentration of reactant is decreased. That means if I take it for this reaction, this value is decreased. If these things are removed from the container where the reaction is proceeding, what will happen? It will try to produce that component because they are removed. So it wants to increase that component. So during that case, what happens? By decreasing the concentration of the reactant, reverse. Reaction takes place and decrease in concentration of product. Forward reaction takes place. Right? Okay. Now, after understanding it, let's have it as in a form of question. If it is given to me, decomposition of PCl5. Decomposition of PCl5. When the concentration of chlorine is reduced, what will be the direction in which the reaction will proceed? Now this is decomposition. That means PCl5 is dissociated into PCl3 plus Cl2. And it's told that if concentration of Cl is reduced, right? Now if the concentration of Cl2 is reduced, what will be the direction? The reaction from it, the Cl is removed, so it wants to increase the quantity of the Cl. Now if you want to increase the quantity of the Cl, what will happen? The reaction has to be proceed in the forward direction. See, we wrote it, if the concentration of the product is reduced, reaction will move in the forward direction. So these you can generalize it for any given reaction. Decreasing the concentration of the product, reaction will proceed in the forward direction. Decreasing the concentration of reactant, reverse direction. Vice versa, increasing the concentration, forward. Decreasing the concentration of the product, will go for, increasing the concentration of the product will go for reverse. Right? So the question will be there for you like that, any of it. Clear? Third effect that we are having, that is related to pressure. Now particularly for the pressure, unless and until the reaction is not written, it's not possible to indicate that the increase or decrease in the pressure will take the reaction in forward or reverse direction. We can't generalize it that increase in the pressure means forward or decrease in the pressure reverse. We can't. The reason is it depends upon the reaction. Let's see how it depends upon the reaction. The first one, if I go in for example, CaCO3, it decomposes into CaO plus CO2. Then in this case, what is going to happen? This is solid gas. The pressure, it affects only onto the gaseous component. It does not affect on the solids or liquids. So whatever the effect you are going to do it during the reaction, it's going to affect only onto the gaseous component. Right? So in this case, if pressure of CO2 is reduced, now see specifically we wrote it CO2 is reduced, right? So reduction in CO2, what will happen? It will increase, so reaction will proceed in the forward direction, right? If pressure in the container I am reducing the pressure in the container, so now I am not specifying that it was CO2, but still in the container what is going to happen? These are the solid, only one is gas. So reducing this component will reduce the pressure. If this component is removed, then only the pressure can be reduced, and if this is reduced, forward reaction takes place, right? But see again I am telling it, for the pressure, effect of the pressure, I won't be able to say that every time reducing the pressure will make the reaction to proceed in the forward direction. The reason is, if I take it as a second example, now these components are in the gaseous state. All of them are in the gaseous state. If I reduce the pressure in this reaction, what will happen? All the three components are going to be affected. And if I want to reduce the pressure in all the three components, that will reduce the pressure of the container. During that case, maximum effect will be on the reactants. Here, maximum effect will be on the reactants. More the reactants are there, less is the product. So more pressure reduced will be for the reactant. So reaction will go for reverse. So in this case, if pressure is reduced, reaction is in reverse direction. For this forward direction, though the condition is same, though the statement for both of these are same, your answer for them are different, and that depends on the gaseous component. Right? So you have to be careful. You have to first of all identify whether the given reaction, what are the number of the components present in it, and what are the physical states of this component. To generalize this particular type of reaction, or to generalize the effect of the pressure, we can calculate it on the basis of delta and changes the number of moles of the gaseous component. We know it in the thermodynamics, we have already studied it. Np minus and our number of moles of product minus reactant will give me the gaseous component. Now in this case, if delta N is greater, means we can say that greater than 0, positive. Delta N is positive. That means the product will be more. The number of the moles of the gaseous component in the product are more. So if delta N is greater than 0, then I can put the condition for it in the generalized form, that if delta N is greater than 0, increasing, I will write it here, if delta N is greater than 0, increasing pressure of reaction, not particularly reagent or not particularly product, it's generalized whole reaction. Specifically when you are doing it, you will have to go for the answer as a concentration, right? Because specifically when I am talking about only NS3, or I am talking about only H2, or I am talking about only N2, then what will happen? I will have to consider its concentration, right? When we are talking it in the reaction, generalized, then only we can apply this. Okay, otherwise individual we will have to go it according to the concentration. Now if delta N is greater than 0, increasing the pressure of the reaction takes reaction in reverse direction. And decreasing pressure of reaction goes in reverse direction, right? Similarly, if delta N is less than 0, then what will happen? Vice versa. Increasing pressure forward. Decreasing pressure reversing action will take place. Okay, so it depends upon the number of moles of the gaseous component present in the given solution. And the fourth factor that we told it, that was the catalyst. Actually, by any catalyst, reaction is not affected at all. Its equilibrium is not affected. Equilibrium remains same. It does not affect the equilibrium. It will reduce the time to reach to the state of equilibrium. Okay. So catalyst, they are not affecting to any of the equilibrium. So that won't affect or don't show any kind of a change in its equilibrium state. Okay. This was your first part of the chemical equilibrium. Now the second part of the chapter, it's going to be based on ionic equilibrium. Till now we were having all the molecular compounds. Now we will be having ions, or ions are produced by ionization or by dissociation, and in it we will be studying related to the equilibrium as an ionic equilibrium, but that we will do it in our next lecture. Till then, thank you.